This video is part 2 that goes with section 12.2, chords and arcs. Here I'd like to finish the last couple of examples on your note page. I know my numbers are a little different, but all the problems should be exactly the same. Most of these problems are dealing with the same concept. We're going to use Pythagorean theorem, the idea of right angles, that third key concept that said as long as there is something going through the center, which is essentially the diameter, that it's cutting the chord into a perpendicular bisector. So having done that, I've created a 90-degree angle with x. This part is 4, this part is 5. A squared plus b squared equals c squared. So I end up getting that x equals 3. For number 5, these are very similar to the ones up above. This is the radius. Once you recognize it as the radius, you can draw it wherever you want to. It goes from the center to the edge. Having done that, you've created a 90-degree, where 2 is that short. Notice 3 is really the hypotenuse because it's across from the 90-degree. The chord is the entire length of x, so I need to call this something different. Call it y. Because x is the entire length. So I'll do that 2 squared plus y squared equals 3 squared. So that's 9 minus 4. Y ends up equaling the square root of 5. On some of the previous problems, I discussed this as well, but you have 2 square root 5s. We're really adding them up here. When we add square roots, you add the coefficients in front. So 1 square root 5 plus 1 square root 5 is 2 square root 5. I need something other than black to write with. It's kind of depressing me. Okay, number 6. This one is slightly different than the other. We do have the things coming through the center, so you can deal with perpendicular bisector. Notice perpendicular, notice they're both labeled x. We won't need Pythagorean theorem here. It's asking you for the length of the chord. Since it gives you that they're both 7, meaning that they're an equal distance from the center, then the chords would have to be the same. So since this chord is 6 and is 7 units from the center, this other chord that is also 7 units from the center would also have to be 6 each. Yeah, they would also have to be 6. So x here ends up equaling 3. Number 7. All right, so x is the entire chord again. I'm going to finish off this triangle because it looks a little incomplete. And if you notice what I've done is I've drawn another radius, so 12 can go over there as well. So right now we have a triangle with both isosceles sides as the radii. This arc is 120, so that means the central angle is 120. I want to find the entire value of x. To do that, I'm going to draw a segment that goes through the center of the circle. So by drawing that through the center of the circle, I'm creating a perpendicular bisector. So really, I have a triangle right here where this piece is 60, this is 90, and I'm going to call each of these y, because I don't want to call them x because x is the length of the whole chord. I see a 30, 60, 90 triangle where 12 is the hypotenuse. The relationship between the short side and the hypotenuse is that it's always half. And then the long side is the short times the square root of 3. You could use, if you wanted to use trig, let me go ahead and finish this off. So if each y is 6 square root 3, then the length of x would be 12 square root 3. When we add, we combine like terms. I know a lot of you don't like 30, 60, 90 triangles, so let's look at this one more time. 6 would be the adjacent, 12 would be the hypotenuse, so we could say, I'm going to do sine of 60 equals the opposite value over the hypotenuse, and it should give you the decimal equivalent, which I didn't even type out, and I don't have my calculator in front of me, so you guys can do that on your own. I guess it's number 8 on mine. I think it's letter E on yours. Very similar concept. I see an 86 as an arc, so I'm going to go ahead and label that in here. but it's not even in the triangle that I'm dealing with. If this is the triangle, x is the length of the radius, 20 is the length of the chord. So this central angle would be the supplement or the linear pair because it lies on that diameter, so it's 180. So I did 180 minus 86 and got 94. All right, so here's my triangle. This is 94. I have 20 here, and I have an x, and I have an x. I'm going to use the concept yet again that says if you make a segment going through the center, that you've created a perpendicular bisector. So I'm going to redraw my triangle. This piece is 10 because it got cut in half. That's still my x. I don't even know or need to know this little distance here. But then I'm cutting 94 in half, so this angle is now 47. In the previous problem, I ended up with a 30, 60, 90, which for me made my calculation easier. Here, however, I'm going to need trig. If 47 is my reference angle, 10 is across from it, opposite, and x is hypotenuse. So the sine of 47 equals the opposite value over the hypotenuse. When the x is down low, switch them, you know. X equals 10 divided by the sine of 47. I had this one pre-typed in my calculator. That's what I got. Hopefully you guys get it too when you check it. This one doesn't need to be doubled because of where the value is. You ended up finding the radius, so it was an x value. You didn't find the chord. Over here you found half of the chord, which is why you added them up. So x was in a different location. Last one might be worthwhile pausing and seeing if you can do it on your own, but I'm going to keep going. I see that 6 is the radius, so 6 is the radius over here. It tells me that that's 90. Again, x is the length of the whole chord. Same concept, one more time. If you cut through there, you've created a perpendicular bisector. I'm going to redraw. So that's 90. I'm going to call this y because I don't want to call it x. This angle was 90 and it got cut in half, so it's now 45, and I have that the hypotenuse is 6. I have a 45, 45, 90 triangle, which I know some of you like and some of you don't, but let's see here. 45, 45, 90, so actually I'm going to do this. Since this is 45, this side is 45, I have an isosceles triangle, so I'm going to say that, oh wait, I don't even have to do any of this. Backed up. Hold on. I'm making this way more complicated. Look, the triangle's right here. If this is 6, and if this is 6, it already gave me that that's 90. I have a right triangle. I can go ahead with Pythagorean theorem. 6, 90, 6. If you recognize it as a 45, 45, 90 because it is, x is 6 square root 2. If you don't, try it. 6 squared plus 6 squared, excuse me, equals x squared. So x ends up equaling the square root of 72, which reduces to 6 square root 2. Sorry. Hopefully that makes that one a little easier than where I was going with it. You probably could have completed it that way. It just would have been a little bit longer. All right, so that concludes the second part of this video. Thank you. Please let me know if you have any questions.